Hi friends, today we are discussing about a very important topic, that is surface tension on liquid droplet. So let me first draw a liquid droplet in order to understand the concept of surface tension acting on the liquid droplet. So I have drawn a spherical form of liquid droplet, friends. So this spherical form of liquid droplet will have liquid filled inside the droplet, and the outside will be the, typically we take air outside, friends. So air is outside, we can say, and inside we have some kind of liquid. So here we have, let's say, liquid inside. Now the surface of this liquid, or we can say the interface between liquid and air, will be under tension, because due to property of surface tension, the surface tries to minimize its area. So in order to minimize the area, this surface always will be under tension. So we need to find out how much tension is acting on it. So the surface tension is basically, it is defined as the force per unit length. Force which is acting tangentially on the surface. So it is force or tangential force acting on the unit length drawn on the surface of liquid. Okay. So we need to find out this surface tension, that is sigma, in case of a liquid droplet. So here we have understood that the inside we have got liquid and outside there is air. Now since the surface is under tension, it wants to minimize surface area. Always there is an inside pressure or inward pressure acting on the liquid. This inward pressure is due to the difference of inside pressure and the outside pressure. So if I say the inside pressure is Pi and the outside pressure is Po, so the net pressure will be Pi minus Po. So I can say here the net pressure acting on the surface will be, I'm going to call this delta P, friends. So delta P is nothing but the pressure inside the liquid droplet minus the outside pressure, that is atmospheric pressure, friends. So this is the net pressure acting on the surface of the liquid. Okay, and this net pressure is due to surface tension on the surface of liquid. So let's see how to derive the expression of surface tension, friends. So I'm going to cut this particular droplet from the center, and I'm going to take the half part of it to analyze it. So let's do that, friends. So if you look at here, friends, I have taken the half part of this spherical droplet. We know that the net pressure acting inside this bubble is Pi minus Po. So Pi is basically the inside pressure and Po is the outside pressure, that is atmospheric pressure. The net pressure which is acting inside will be something like this, friends. I can draw it like this, for instance. So net pressure acting inside is delta P. So we also know that the surface of the liquid or the interface between liquid and the air will be under tension. So there will be always a force acting on the circumference of the surface. So let me show that force over here, friends. So you'll be seeing a force is going to act on the circumference of the surface like this. All over the circumference there will be force acting like this. What I can show it here. So this is the force F, which is due to surface tension. Okay, and there is a net pressure acting inside the droplet. So under the equilibrium condition, when the surface formation takes place, this force which is acting on the circumference must be able to balance the inside force caused by this pressure. The force which is coming on this internal surface must balance the force acting on the circumference. Okay, so that way the force caused by the pressure over this cross sectional area, that force is going to be the pressure into the area of the cross section, friends. So pressure is basically delta P, net pressure, times the area of cross section is nothing but, if I say the diameter of this droplet is d, so the area of the cross section is going to be pi over 4 d square. So this is the force acting on the cross section due to the pressure difference between inside and outside pressure. This force must balance the force caused by surface tension. So we already know that, friends, surface tension is what? Force per unit length. So here circumference is going to be 2 pi r. The length of the circumference is 2 pi r, friends. So the force will be surface tension times length. So surface tension is sigma, friends, and the length is nothing but the circumference of this droplet. So it is going to be 2 pi r. R is nothing but d by 2, friends. So pi r means d by 2. Simply we can take it as pi into d. If you see, 2 will be getting cancelled out, so it is pi d only. So if I equate this equation, I'll be able to get the expression of sigma. Now if you see here, we have d square will be cancelled by d, 1 d will be remaining here, friends. Okay, and 1 pi is getting over here in the left hand side, will getting cancelled by this because both are equal. Okay, so what is remaining? Let's see what we have balance over here. So we have got in the left hand side delta P, difference in the pressure, times D whole divided by 4 over here, friends. In the right hand side we have sigma, only sigma is there, friends. Okay, remaining things are got cancelled out. So from here we'll be getting very simple outcome of surface tension for a liquid droplet as delta P times diameter over 4. So friends, this is the expression for surface tension of a liquid droplet, which has net pressure inside as delta P, diameter as D. So in that case you can find out the sigma equal to delta P D by 4. And if you want to find the delta P, difference in the pressure, if surface tension is given to you, so you can get delta P as what? 4 sigma times D. So you can also find out the difference of pressure between inside and outside when there is a formation of droplet for a surface tension given to you. So this is delta P equal to 4 times sigma by D. So both the expressions are important for us. We can use them. So we'll do one simple example based on the concept. So let's see, we've got a very simple example here. So pressure outside the droplet of water of diameter 0.05 mm is 1.0133 bar. So basically this pressure is the outside pressure, friends. Calculate the pressure within the droplet if the surface tension is given as 0.07 newtons per meter of water. So basically this is the standard value of surface tension of water at around 20 degrees centigrade. Okay, so let's see how we can find out the inside pressure when the droplet is formed having diameter 0.05 mm. Let me first write down the data available to us. So diameter of droplet is given to us, friend, that is 0.05 mm. So we can use the SI unit, so it will be 0.05 into 10 raised to minus 3 meters. The second thing is the pressure inside the droplet. So if I draw a droplet here of the spherical form, so the inside pressure they have given as, which is acting like this, friends. So let me say that is inside pressure is Pi, and the pressure acting from outside, which is nothing but the atmospheric pressure, we can say something like this, friends. Please remember, the pressure inside is due to formation of the surface. When surface is formed, that will create an inside pressure. Okay, so in order to balance between inside and outside pressure, the surface tension is going to play the role. Okay, so this is Pi, inside pressure is Pi and the outside pressure is Po. So they have given the outside pressure, friends. So Po they have given, which is nothing but 1.0133 bar. So again we have to convert this into SI unit. So for that you'll have to multiply by 10 raised to 5 and then it becomes newtons per meter square. So both are in SI unit here. So the outside pressure, atmospheric pressure, is given as 1.0133 bar. So we have converted into SI unit, that is Newton per meter square, by multiplying it by 10 raised to 5. So we have got here the expression, that is the delta P, the difference of pressure, is given by 4 times surface tension by diameter. So I'm going to use same thing over here, friends. So I can say that delta P, that is difference of pressure between inside and outside the droplet, that is 4 times surface tension over diameter. Now they have also given us the surface tension of water, and that value is 0.07 newtons per meter. So it is going to be 4 times 0.07 divided by diameter of droplet is given as 0.05 into 10 raised to minus 3. The delta P is basically the difference of inside pressure and outside pressure. So you'll be getting from here inside pressure minus outside pressure of droplet, and will be this value, friends. If you calculate this value, friends, you'll be getting this as 5600 units. So from here the inside pressure, that is Pi, will be written as 5600 plus the outside pressure, that is Po, and the Po we have already got here, friend. It is 1.0133 into 10 raised to 5. So when you add these two values, you'll be getting the inside pressure would be 106930 newtons per meter square. If you want to convert this into bars, you have to divide it by 10 raised to 5. So it will be coming as inside pressure will be around 1.0693 bar. This is how you can easily calculate, friends, the inside pressure when a droplet of 0.05 mm is formed under the atmospheric condition of 1.0133 bar for water which is having 0.07 Newton per meter of surface tension. So like this we can easily solve the problems based on the surface tension of liquid droplets.